Hello, good afternoon to all of you. I hope all of you are doing well. In today's class, we are going to discuss principles of object-oriented programming. Now, to begin with, let us focus on an important aspect that is called a software crisis. As we all know, with time, there has been continuous advancement in technological domain, as a result of which now what we have hardware systems that are capable of sustaining complex computational program. By complex computational program, I'm trying to refer to software systems that are functionally sound and structurally stable. Now, in addition to this, with time, there has been tremendous increase in the demand of the customer for development of complex systems. As we all know, associated with development of complex systems, there lies in a set of inherent challenges. So software crisis basically tries to relate to issues concerning increasing software demand, the associated software complexities, and associated inherent challenges, and the problems that are arising out of it, like issues concerning software budget problem, software efficiency problem, software quality problem, software project management problem, and software delivery problem. Now let us try to identify or go through some of the important causes for software crisis. First and foremost, because of the ability of the hardware, now what we have complex software systems being developed that are difficult to own and maintain. So the cost of owning and maintaining software system has tremendously increased. Now, project running over time, it may so happen that the overall software development time may exceed the expected time because of the associated inherent challenges that are there with the software development. So it may so happen that the software development may take more than expected time. Inefficient software. It may so happen that the software system that is being built is not capable of delivering the expectation of the customer in terms of precision, in terms of correctness, in terms of the quality of the results. So a software system may be a highly inefficient software. Low quality software. So if the software system is not correctly implemented, it's not capable of delivering result within expected time, and it does not meet up to the expectation of the customer, so definitely a software system will be considered as a low quality software. Inability of the software to meet customers requirement. It may so happen that you may build up a very good software, but if it does not meet up with customer expectation, then a software system may be eventually rejected by the customer. Software system is often delivered late. It may so happen that you had not anticipated the associated complexities, because of which the software development time has exceeded than the expected time, because of which the software system is delivered late. Now, these are some of the notable causes for software crisis. Increase in the cost of owning and maintaining software system, project running over time, building up an inefficient software system, building up a low quality software system, inability of the software system to meet up with the customer's expectation, and it may so happen that software systems are often delivered late. Right? So these are some of the notable causes for software crisis. Now, in order to face up to the software crisis, what we need to do is we need to identify some of the key issues. So, following are some of the issues that needs to be addressed to face up to the software crisis. First, and the most important thing is one should know how to represent the real life entities of the problem in system design. One has to know the mechanism for selecting or electing the appropriate real world entities, and one should be capable of translating the real world entities into logical objects, and one should be capable of representing the objects in terms of classes and relationship, and one should be capable of translating the classes and relationships into executable to represent the system in logical world, or the objects in the logical world. So one has to know the mechanism for representing real life entities of the problem in system design, because until and unless there is no proper correlation between the real world entities that are participating in realizing the business to the logical objects that are participating in realizing the business and design, the interpretation of the system may be completely wrong. So one should be capable of creating a complete compliance between the real world entities and the logical entities that are participating in system design. Because if the design goes right, then the implementation of the design into set of executable code will also definitely go right. So that is what we need to ensure. We need to know how to represent the real world entities of problem into system design. Now, how to design system with open interfaces? One should be capable of distinguishing between the roles that are played by different objects in realizing a system. One should be capable of differentiating between business objects and interfacing objects, because unless you're not capable of distinguishing between business objects and interfacing object, you may not be capable of communicating the information that is generated by the system into the environment through the intended environment. So it's very much important that interfaces are properly designed by identifying in the interfacing objects. Now, how to ensure reusability and extensibility of the model? Definitely, one of the prime focus of object-oriented paradigm is to ensure reusability and extensibility of the modules. By reusability basically refers to by reusability we are trying to refer to organization of a system as a collection of modules that can be reused in future system that may be built. So reusability, what it not only ensures correctness, but it also ensures quality, and further what it ensures profitability for your organization, because by organizing a module as a system as a collection of reusable module, what you can do is you can readily pick up a module from a given system to a new system that is being built. So it ensures quality, it ensures correctness, it ensures profitability, it ensures testability, and so on and so forth. And extensibility of the module is the ability of the module to adapt to certain changes for enhancing its ability. So one should know how to reuse the modules and how to extend the behavior of the module. Now, the next important focus is on how to develop modules that are tolerant to any change in the future. So, it is very important for us to build up a change tolerant collection of module, because it will not only ensure usability, but it also ensure popularity of a software system. So, for an example, if you're using a software application in Windows environment, and with minimum change, if the system can be ported into some other environment like Linux environment, then definitely the usability of the module is enhanced, which will further ensure popularity of that particular module. Now, how to improve software productivity and decrease software cost? So, if you have a set of skilled labor force, if you have a set of well-defined reusable modules, then definitely what will happen is that your productivity will increase. So, increased software productivity basically means the ability of the organization to deliver software product. So by having a skilled labor force and by having a set of reusable high quality module, what you can do is you can improve software productivity. And further, by improving software productivity, the overall cost for software development also decreases. So, what we have is we have a transitive effect there. So, by improving software productivity, what we can do is we can decrease the quality of the software, decrease the quality of the software product. Now, how to improve the quality of the software system? Because this is one key focus point of software development: how to ensure quality of a software system, how to ensure correctness, how to ensure reliability, how to ensure security. So these are the important features how you can improve the quality of the software system, and how to manage time schedule, and how to organize the activities that are to be performed for developing a software system so that you meet up to the deadline set by the customer. So that is an important activity in case of software development life cycle, that's called as planning. So this is an integral part of planning, how to manage the time schedule. So these are the key important some of the key issues that needs to be addressed to face out a software crisis. So how to represent real life entities of the problem to system design, how to design system with open interfaces, how to to ensure reusability and extensibility of the module, how to develop modules that are tolerant to any changes in the future, how to improve software productivity and decrease software cost, how to improve the quality of the software system, and how to manage the time schedule. So if you can address all of these key questions, then what you can do is we can face up to the software crisis. Now, let us try to identify some of the quality issues that should be considered for critical evaluation of a software system. First thing is correctness. Now there has to be complete compliance between the interpretation of the problem in the real world and interpretation of the problem in the logical world. Right, so there has to be complete correlation between the real world entities and the logical entities that are participating in design and subsequently the implementation of the system. So then what we can do is we can ensure correctness of the system. So correctness can be ensured by creating a compliance between the real world and the logical world. Now maintainability is one key aspect of software development. Now, in order to ensure maintainability, there are some focus points that you need to understand. Now, something that is readable is understandable, something that is understandable is acceptable, and something that is acceptable is maintainable. So in order to ensure maintainability, a software system has to be readable, a software system has to be understandable, a software system has to be acceptable, and eventually then only it can be maintained. Now in order to ensure readability of a software system, a software system should exhibit a very high level of uniformity in the way how the variables are represented, uniformity in the way how the modules are represented, uniformity in the way how the documents are created. So it is very important for one to adhere to certain guidelines for coding, certain guidelines for preparing document for ensuring maintainability. Now maintenance can be carried out for various reasons. Maintenance can be for adaptation, it can be for correction, it can be for perfection, it can be for prevention. So we can have adaptive maintenance, we can have corrective maintenance, we can have preventive maintenance, we can have perfective maintenance. So different types of maintenance may be there, may be initiated, but first and foremost we need to ensure that in order to enhance maintainability, a module has to be really readable. That can be done only if the uniformity of representation is maintained for in various artifacts that are being generated. Now reusability, as we have already said, a system has to be organized as a collection of reusable modules. So reusability not only ensures correctness, but it also ensures quality, it ensures testability, as well as it ensures a ton of profit for your organization. Openness and interoperability and openness basically tries to address the issues like the ability of the system to interact with the other systems that are there in the environment to realize a particular business. So a system that is being generated, a system that is being created should be interoperable in nature so that it can interact with the other systems that are there in the environment, and collaboratively it can realize certain business. And openness basically ensures, so if you build up a system in an open fashion, it basically ensures the enhancement in the quality of the software product. It so happens, right? Okay, so openness and interoperability is one key quality issue. Now portability basically tries to address to the ability of the system to adapt to new environment, as we already discussed in the previous slide. So portability basically ensures usability and further popularity of the software system. Now security, a software system should be capable of ensuring the security of the business that is being performed and security of the output that is being generated. So then only what we can do is we can say that a software system is really reliable, and it is capable of supporting certain amount of integrity, or it's capable of providing integrity. Now next important factor is integrity. integrity. Integrity is key. Key as integrity basically refers to the ability of the system to stand to the context for which the system is actually being built for, right? So the if the system is capable of standing for the purpose for which the system is being built for, then what we can say is we can say that a system exhibits certain amount of integrity. Now, user friendliness and usability. Now, this is one of the key issue that needs to be addressed. A system, no matter how complex it is in its orientation and in its functionality, if it is not user friendly, then it may not be put to use at all. So a system that's being built has to be built in a manner that it is user friendly. Only if it is user friendly, then the usability of the system will be enhanced. Now, we all know that Windows operating system is one of the most popular operating system that is used around, but we have been having more stable operating system compared to that of Windows. But Windows, it's a widely used operating system because you must have seen the different versions of Windows operating system that has been released has similar orientation in terms of its look. Because if you have an experience about using any one of the Windows operating system, then what you can do is you can use all other Windows operating system. So this is the way how the organization of the Windows operating system has been done. So it enhances user friendliness, which in turn enhances the usability of the software system. Now, reliability is one key aspect that one needs to focus on. Reliability is the ability of the system to generate the expected result. Right? So, more the capability of the system in generating the expected result, more reliable the system will be considered, and more will be the confidence of the customer onto the system. Now, efficiency basically refers to the ability of the system to generate the result within certain stipulated time. So, efficiency is also one key factor in terms of real-time system, because real-time systems are systems where there is associate deadline with the generation of the outcome, and so on and so forth. So efficiency is also one of the important factor. Now, scalability is basically a feature or issue that tries to enrich a software system by incorporating into it additional features. So a system has to be built in a scalable manner so that it can incorporate in it new features in order to adapt to the changing requirement of the customer. So a system has to be really scalable. And testability is basically an issue that concerns the ability of the system to generate uh, certain deliverables that are rather measurable. So if an example, it is testability ensures correctness. So if a system is not testable at all, then there is no other mechanism for determining the correctness of implementation of the system. So system has to be definitely testable. And modularity. Now, modularity is one key aspect of software engineering paradigm that tries to organize a system as a collection of modules that are cohesive in nature. That means a module that exhibits very high functional strength and with minimum amount of dependency. So modularity basically tries to emphasize on organization of system as a collection of interacting modules with lesser amount of dependency. So these are some of the quality issues that needs to be considered for critical evaluation of a software system: correctness of implementation, maintainability, reusability, openness and interoperability, portability, security, integrity, user friendliness, further leading to usability, then reliability, efficiency, scalability, testability, and modularity. So these are some of the quality issues that needs to be taken into account for critical evaluation of a software system. Now let us see how the software evolution has taken place in terms of paradigm. Okay, so software evolution can be organized into distinct layers, where what we have is we have machine language, we have assembly level programming, we have procedure oriented programming, and then what we have is we have object oriented programming. Now, machine language is nothing but a language where the program is represented in terms of binary digit, that is zeros and ones. Now, eventually, whether you write your program in assembly label language or procedure oriented language or object oriented language, it has to be eventually translated into zeros and ones, because computers are only capable of understanding zeros and ones. So machine language basically means a language where which is used to represent a program in terms of zeros and ones. Now, then onwards, what we had assembly language. Now, assembly language is a low-level language defined for a particular architecture, where what we have is we have a set of instructions defined for a particular architecture. Associated with the instructions, what we have is we have mnemonic code, and mnemonic codes are nothing but associated with the instructions. What we have is we have operation codes. Operation codes are nothing but the binary code that is used to represent that particular instruction or create an interpretation of that particular instruction to the computation system. So assembly language is a low-level language where the programs are written using the mnemonic codes, where mnemonic code basically refers to the instruction that's to be performed. And for each and every architecture, what we have is we have a well-defined set of mnemonic code. Associated with the mnemonic code, there are operation codes. Operation codes are nothing but binary codes that create an interpretation or that create a representation of that particular operation. So whenever a particular binary code is given to a computation system, it creates an interpretation of what kind of operation that is to be performed, right? So a typical example of this would be 8085 programming, where what we have is we have a set of instruction. Associated with set of instruction, we have operation code. So whenever we need to provide a particular whenever we need to perform a particular instruction, the associated operation code is provided to the 8085 microprocessor. The microprocessor performs the desired activity. Whereas in case of microprocessors like 8086, where what we have is we have the instruction set well defined. Associated with the instruction set, what we have is we have the mnemonic code. But in order to ease the work of translating the instruction into mnemonic code, we have programs called as assemblers. Okay, so assemblers are programs that are capable of translating the instruction code into the machine code and feed it into the computer system for performing a particular action, right? Then what we have is we have procedure-oriented programming. Procedure-oriented programming is a programming model where what we do is we organize a program as a collection of procedures, where procedures are a set of instructions that is capable of performing some desired activity. So procedures, also known as routines or subroutines of function, that creates that consists of a series of computational steps to be carried out in order to attain a particular objective. Now, in case of procedure-oriented programming, emphasis is given to procedures. Whereas in case of object-oriented programming, emphasis is given to objects. So in case of object-oriented programming, the programming paradigm is based on the concept that is called as object. Around the object, what we tend to do is we tend to identify the set of the attributes, and to perform operation and attributes, what we tend to do is we tend to identify the methods. So first what we do is we try to identify the object, and then what we try to do is we try to associate attributes, and then what we try to do is we try to identify the method that performs operation on the attributes of the object. So that's the way how the different paradigms are the object oriented, especially the object oriented paradigm, is being conceptualized. So we have machine level programming, we have assembly level programming, we have procedure level programming, and we have object oriented programming. So these were the basic platforms that are there. Now let us try to elaborate more on procedure-oriented programming. Now in procedure-oriented programming, the problem is viewed as a sequence of operations to be performed. So here what we do is we give more emphasis on the modules than on data, right? So here in this particular diagram, what we have is we have the orientation of the various procedures in a given program. So we have main program, or we have main function. So associated main function, what we have is we have set of functions from function 1 to function 8, which has invoking relationship in between them. So main invokes function 1, 2, and 3. Function 1 and 2 invokes function 4. 2 and 3 invokes function 5. Function 4 invokes 6 and 7. 5 invokes 7 and 8. And function 2 invokes 4, 5, and 7. So just see, what we have is we have the programming viewed as a collection of functions or procedures which have invocation relationship in between them. So here what we have is we have the calling function, and we have function that is being called. The calling function invokes the function, and the function being called responds to the calling function. Now this is a typical orientation of a procedure-oriented program. Now let us try to understand some of the important characteristics of procedure-oriented programming. Now in case of procedure-oriented programming, the program is organized as a collection of procedure, where a procedure can be interpreted as a list of instruction that is capable of performing certain operation, right? So procedure-oriented programming basically consists of writing a list of instruction for the computer to follow and organize this instruction into group known as functions. In a multifunction program, many important data items are placed global so that they can be accessed by all the function. Each function may have its local data as well. Now, it may so happen that a particular data item may be required by multiple functions in a given program. So, in order to prevent multiple declaration of the same data, what we tend to do is we tend to place the data globally, and the global data is being accessed by all the function. Now, one of the major disadvantage of placing the data global at a global space is global data are much more vulnerable to any change by the function. So, any intentional or unintentional change may can be brought about into the global data, right? So making the global data much more vulnerable. In a larger program, it's very difficult to identify what data is being used by which function, because it may be difficult for us to track what are the functions and what kind of changes are being brought about by those functions into the global data. Now procedure oriented approach do not model real world problem very easily, because as we have already said that procedure-oriented programming tries to interpret a system as a collection of interacting functions rather than objects. It may be difficult for one to create a very good correlation between the program that is being built and the real world problem that is there. This is because functions are action oriented and do not really correspond to the elements of the problem. So this is one important lag of the function oriented approach, that it does not to an extent correlate to real world, because it does not work on entities, right? So emphasize on doing things, that is algorithm. More emphasis given to the algorithm. Now large programs are divided into smaller program known as function. Most of the functions share global data. Data move openly around the system from function to function. Function transform data from one form to another form. Employs top-down approach in program design. So these are some of the important characteristics of procedure-oriented programming. So here what we need to understand is we need to understand what is a procedure. So we have already specified here. It's a procedure is a list of instruction that directs the computer to perform a desired operation, and it's known as function. In order to prevent multiple declaration of a variable, what we do is we place the frequently used variable in a global space, but globally placed variables are vulnerable, because many function may intentionally or unintentionally change the value of the global variable. And when the program size increases, it may be very difficult to track what all changes are being brought about, which all functions into the global data. So this basically makes procedure-oriented programming an approach not usable for a larger problem. And procedure-oriented programming does not completely correlate to the real world situation, because as the emphasis is given on function, not on object, it may be very difficult for one to create a correlation between the logical interpretation of the system and the real world situation. So these are some of the characteristics that are exhibited by procedure oriented programming. Now let us try to move on to some of the aspects of object-oriented programming. Now, in case of object-oriented programming, object-oriented removes some of the flaws encountered in case of procedure-oriented programming. So, one of the major flaw of procedure-oriented programming is that it's not capable of creating a complete compliance between the real-world entity and the interpretation of the problem, logical interpretation of the problem. So, that is what object-oriented programming tries to address to. So, object-oriented treats data as critical elements in case of program development, and does not allow it to freely move around in the system. So, in case of object-oriented paradigm, emphasis is given more on the data rather than on function. So, by data here, what we basically mean is we basically mean the entities, because data is a correlation for is a representation of the entities, and entities will be representation for the object. So, if you are capable of identifying the objects, then what we can do is we can easily identify. If we can identify the entities, then we can easily identify the attributes, and we can easily identify the methods further. And by creating a representation of the entities in terms of object, what we can do is we can build a very healthy system. Now it so in case of object oriented programming, the other important aspect is that it does not allow for placement of data at a global space. Or what we can do is we can place it in other manner, that objects are responsible for managing their own data, right, and methods. So objects, what they do not do is they do not share their data and methods with the other objects. So here, one of the important aspect that object-oriented programming focuses on is that in case of object-oriented programming, the objects maintain their own data and their methods that they perform on the data, right? So some other external objects that wants a business to be performed by a particular object, then a request message is being sent by the sender object to the receiver object. The receiver object performs the operation and returns the result to the sender object. Now, just see here, one key important aspect that I have emphasized upon is that objects interact by passing messages. So here, what we don't have is we don't have invocation relationship between object. That further tries to ensure security, because if you are not capable of invoking a function, right, then you may not be capable of knowing the address of that particular function, because we'll come to that particular point later in the subject. So if you cannot invoke a function, then you may not be able to work with the internal content of that particular function. So the integrity of the function is preserved. In case of function invocation, what we do is we call the function by passing the address. So in case of function invocation, what we know is we know the address of the function in the computation memory, in the computer's memory. So if we know the address of the function in the computer's memory, then what we can do is we can bring about any change to the function or the behavior of the function. But if we do not know the address of the function, then what we cannot do is we cannot bring about a change in the so that ensures security of the function as well. So in case of object-oriented architecture, since the objects communicate by passing messages, there is no question of invocation relationship, further leading to no question of the behavior of the object being changed. Please do not get confused. It will come later in the chapter, later in the curriculum, the actual benefits of message passing over invocation. So, in case of object-oriented programming, the object maintains their own data as well as function, and whenever a sender object wants to get a work done, so it sends message, the receiver object receives it, and the receiver object realizes the business and returns the message back to the sender object. Now, object-oriented programming allows decomposition of the problem into a number of entities called objects and then build data and functions around these objects. So this we have already understood. Now, the data of an object can be accessed only by the function associated with the objects. That's what I've been trying to emphasize upon. So the attributes of the data or the attributes of the object can be worked upon by only the functions that are defined for that particular object. So data of an object can be accessed by only the function associated with the object. However, function of one object can access the function of another object. That is only through message in passing, right? So that's only through message passing. So one object can pass message to the other object for exhibition of a particular behavior, but the address of the behavior will be hidden from the sender object. So these are some of the important characteristics of object-oriented programming. So here what we have is we have a very simple orientation. So object A, object B, and object C, where object A and B and C communicates with each other by passing messages. Now, some of the features of object-oriented programming. So this is very important for one to understand. So it emphasizes on data rather than on procedure. Programs are delivered into what are known as objects. So it realizes a program as a collection of objects. Data structures are designed such that they characterize the object. So object maintains their own data as well as functions. Functions that operates on data of an object are tied to the together to the data structure. So object maintains their own data in a particular data structure along with the function. The function performs operation on the data structure, right? Now data is hidden and cannot be accessed by external function. This is an important aspect. Object may communicate with each other through function in terms of message communication. So one object can interact with another object by passing messages. So as I've already said, if a particular behavior is to be exhibited by an object, so the sender object sends a message to the receiver object. The receiver object selects the desired behavior, performs the operation in response to the sender object. New data and function can be easily added whenever necessary. So this is one of the important feature that we'll learn in case of object-oriented programming, right? And it follows bottom-up approach in program design. Okay, so this is an important aspect. So in case of procedure-oriented approach, it was top-down. In case of object-oriented, it's bottom-up, right? So these are some of the important features of object-oriented programming. So in today's class, what we have learned about is we have learned about the software crisis. Okay, we have learned about software crisis. We have learned about what is software crisis. We have learned about what are the causes for software crisis. We have learned about what are the issues that needs to be addressed for facing the crisis, right? We have learned about some of the quality issues that needs to be considered for critical evaluation. We've learned about the way how the evolution has taken place in programming paradigm from machine language to assembly language to procedure-oriented language to object-oriented language or object-oriented programming language, right? So we have learned some aspects about machine language, assembly language, procedure-oriented programming, and object-oriented programming. Okay, then we have learned about procedure-oriented programming in detail. We have learned about the way how the modules are oriented. We have learned about some of the important characteristics of procedure-oriented programming. Then we moved on to object-oriented programming. We've learned about some essential features of object-oriented programming. We have learned about the way how the organization has been done. We have learned about some of the important features of object-oriented programming as well. Okay, so in today's class, we have learned about software crisis. We have learned about various aspects of software crisis. We have learned about different types of programming paradigm, and we have learned about the characteristics of the different paradigm. Okay, so in next class we will continue with the basic principles of object-oriented programming. Thank you very much.